This video shows solutions using direct methods in evaluating systems of linear equations. You are watching numerical solutions to C problems. We are to look for the values of the variables r, s, t, and w given the four equations. In this video, we will use direct methods, Gaussian and also Gauss-Jordan elimination, for you to see which approach is more comfortable for you to work with. The first method we will use to find the values is through Gaussian elimination without pivoting. From the four equations, generate an augmented matrix using the coefficients and the constants. After which, arrange the rows in a manner that will help you zero out other elements easily. In this case, we adopt the first row as the first pivot row. It is because its leading element is 1, and by this value, it is easier to zero out the other elements in the first column. Let's start zeroing out element 2, 1, and we are to use the first row as pivot row, even for all the other elements in column 1. For the second row, the row operation used is R2 less 4 times R1 as the new R2. By using this operation, the first column has 4 less 4 times 1, giving 0. This is our main goal. Work on the rest of the elements in the row. For column 2, we take negative 3 minus 4 times 2, which results to negative 11. The next element then becomes 1 minus 4 times of negative 3, giving 13. From column 4, we take negative 2 minus 4 times 1, which makes negative 6. The last column then becomes negative 10.7 minus 4 of negative 9.25, which makes positive 26.30. Now zero out element 3, 1 by using the pattern row 3 plus twice of row 1 as the new row 3. The first element in row 3 then has negative 2 plus twice of 1, making it 0. Next is 4 plus twice of 2, giving 8. From the third column, there is 2 plus twice of negative 3, making negative 4. The following element has 3 plus twice of 1, making 5. And the last element works on 16.75 plus twice of negative 9.25, giving negative 1.75. Next is to zero out element 4, 1. The row operation to use is R4 minus 3R1 as the new R4. For the element in the first column, there is 3 minus rise of 1, making it 0. The next element is negative 2 minus rise of 2, and that is negative 8. The following element is 3 minus 3 times negative 3, giving 12. The element for the fourth column has negative 2 minus rise of 1, making it negative 5. The last element has 0 minus rise of negative 9.25, making 27.75. So we had zeros right below the leading element in column 1. We are to proceed to zeroing out the other elements, and the first step is to identify the pivot element from the rest of the elements. We specifically focus on the elements in the second column. From negative 11, 8, and negative 8, we use positive 8, although you can choose the others and still arrive with the same result. As the leading element of positive 8 is found in the third row, let us interchange rows 2 and 3 to have 8 at its supposed to be location. With the transform matrix, we now focus on the second column. and we will be using the second row as the pivot row. To eliminate element 3, 2, we use the operation R3 plus 11/8 of R2 as the new R3. For element 3, 1, there is 0 plus 11/8 of 0, still giving 0. The next element has negative 11 plus 11/8 of 8, giving 0. The third element is 13 plus 11/8 of negative 4, and that is 7.5. The element after is negative 6 plus 11/8 of 5, which is 0.875. Then the last element in the row has 26.3 plus 11/8 of negative 1.75, making 3823 upon 160. Now eliminate 4, 2 with the operation row 4 plus row 2 as the new row 4. The first element then has 0 plus another 0 for the other row, giving also 0. The next element has negative 8 plus 8, making 0. The third element has 12 plus negative 4, making 8. The fourth element has negative 5 plus 5, which is 0. The last is 27.75 plus negative 1.75, giving 26. After completing the second column, work on the third. And again, the initial step is to identify the pivot element. Say that this time, we choose 8 from row 4. So interchange rows 3 and 4. With the transform matrix, and using row 3 as the pivot row, zero out element 4, 3. So the row operation to be used is R4 less 7.5 over 8 times R3 as the new R4. The first element is then 0 less 7.5 over 8 of 0, resulting to 0. The element in the second column is 0 minus 7.5 over 8 of 0, which is still 0. The third element in the row is 7.5 minus 7.5 over 8 of 8, making 0. Then for the fourth column, there is 0.875 less 7.5 over 8 of 0, leaving the same 0.875. Then the last element is the ratio of 3,823 and 160, less 7.5 over 8 of 26, leaving negative 77 over 160. Since we are exploring Gaussian elimination, the matrix is completed at this stage. Also take note that each column has its own variable designation, as R for column 1, S for the second column, the third is T, and the last is W. From here on, work on the values using algebra and back substitution. So checking on the last row, we have 0.875W as negative 77 over 160, where W comes as negative 11 over 20, or that is negative 0.55. Moving a row upwards, revert the third row into an equation. We get 8t plus 0w is 26. So t is then 13/4, which is 3.25. Move another row higher and interpret the elements into an equation, which becomes 8s minus 4t plus 5w is equal to negative 1.75. Since we already have figured out t as 3.25 and w as negative 0.55, plug them into the equation, making it 8s minus 4 of 3.25 plus 5 of negative 0.55 is negative 1.75. S then becomes 7/4 or 1.75. The last variable can then be evaluated using the first row, which then turns into R plus 2s minus 3t plus w as equal to negative 9.25. Substituting the other values into the variables, we get r plus twice of 1.75, minus 3 of 3.25, and negative 0.55 is equal to negative 9.25. R is then computed as negative 2.45. These are the values of the variables in the problem. In case you might want to check how the problem is solved using Gauss-Jordan, start with the updated matrix from Gaussian elimination. Since we needed to eliminate all other elements except those in the diagonal, we need to work from the bottom to the top. By using the fourth row, we focus on the fourth element. Use this as pivot element and work upwards. Although from the example, we don't have to zero out the element on top of 4, 4, as it is already 0. We then move a row higher, eliminating element 2, 4. Use the operation R2 minus 5 over 0.875 of R4 as the new R2. The first element is 0 minus 5 over 0.875 of 0, yielding 0. The next is 8 minus 5 over 0.875 of 0, leaving 8. The third element then is negative 4 minus 5 over 0.875 of 0, making negative 4. The fourth element is 5 minus 5 over 0.875 of 0.875, making 0. The last element in the row has negative 1.75 minus 5 over 0.875 of negative 77 over 160, making 1. Next is to zero out element 2, 4. Using R1 minus R4 over 0.875 as the new R1. For the first element, there is 1 minus 1 over 0.875 of 0, making 1. The second element is 2 minus 1 over 0.875 of 0, and that is 2. The third is negative 3 minus 1 over 0.875 of 0, resulting to negative 3. Then next is 1 minus 1 over 0.875 of 0.875, making 0. The last element is negative 9.25 minus 1 over 0.875 of negative 77 over 160, giving negatives 8.70. With the elements in column 3 zeroed out, except 3, 3, move on to zero out the others in column 2. This time, using row 3 as the pivot row. The operation is row 2 plus half of row 3 for the new row 2. The first element is then 0 plus half of 0 as 0. The next has 8 plus half of 0, which is still 8. The element right after is negative 4 plus half of 8, which makes 0. The element in the fourth column is 0 plus half of 0, which is again 0. The last element has 1 plus half of 26, which is 14. Next is to focus on the first row. To eliminate element 1, 3, use the operation R1 plus 3/8 of R3 as the new R1. So for the first element, 1 plus 3/8 of 0 is 1. Next is 2 plus 3/8 of 0 leads to 2. The third element is negative 3 plus 3/8 of 8, giving 0. Then, 0 plus 3/8 of 0 is again 0. For the element in column 5, negative 8.7 plus 3/8 of 26 is 1.05. Now we are at the last element elimination, and that is element 1, 2. Use row 2 to eliminate element 1, 2 by using the operation R1 minus a quarter of R3 as the new R1. So from the first column, take 1 minus 0 over 4 to give 1. The second element has 2 minus 1/4 of 8, which makes 0. The element on the third column is 0 minus 1/4 of 0, making 0. The next element is 0 minus 1/4 of 0, which is still 0. The last element is 1.05 minus 1/4 of 14, and that is negative 2.45. After zeroing out all elements, except those in the diagonal, remember that in Gauss-Jordan, the remaining elements should be 1. Thus, divide the elements in rows 2 and 3 by 8. Then row 4 should also be divided by 0.875. And now that we have the desired matrix, we can easily find the values of each variable. From the first row, R is identified as negative 2.45. From row 2, we can deduce that S is 1.75. T is taken from row 3, giving 3.25. Then W is negative 0.55 from row 4. As you can see, no matter which method to use, the values of the variables would still remain the same.